Welcome to today's webcast, brought to you by LightStep. I'm Stephen Fegg, Director at Database Trends and Applications in Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled, The Complete Guide to Observability. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the Submit button. We'll try to get to as many questions as possible, but if your question has not been selected during the show, you will receive an email response. Plus, all viewers today will be entered to win a $100 American Express gift card. Now, to introduce our speaker for today, Austin Parker, Principal Developer Advocate at LightStep. For more information on Austin, you can click on the arrow under his headshot. Now I'm going to pass the event over to you, Austin.
Great, thank you. Good morning, everyone. Good afternoon, depending on where you are. Like I said, I'm Austin Parker. I'm a Principal Developer Advocate here at LightStep. And today, we are going to be talking about observability, the complete guide to observability, if you can believe it. And some of you, if maybe you've heard of observability or you've seen the term around, and you're not quite sure what it is, or you know what it is, and you're looking for kind of more in-depth information, well, the good news is we're going to give you a lot of it here. So I think we should get started. Fundamentally, observability ties into this concept about the complexity of software, right? If you think about your daily life and you think about basically everything you've done since you woke up this morning, software has touched you in some way, right? Your alarm going off, reading the news, joining us on this webinar, right? You are participating in this incredibly complex and complicated software economy that we have built. And you, in your role, maybe you're an executive or you're an engineering manager, or you're a developer, or whatever you are, right? Your organization, success of your company in large part depends on the software that you build. And these software systems are becoming increasingly complex. Now, why does that complexity exist? In some ways, it's because we've decided to modernize our software, right? Now, that modernization can be, synonymous with migrating to the cloud, or using Kubernetes, containerizing our applications, or other sort of, things like that, where we are changing the way that we really write software and run software, right? We've decomposed sort of these traditional monolithic architectures into smaller and smaller services. Now, that leads to pretty naturally either a service-oriented architecture or even a complete micro-service-based distributed system. And those are great. Those solve a ton of problems, but they've also created their own really kind of new and special set of problems. These problems are really endemic to what we're calling deep systems, right? Systems where you have a bunch of different layers. And a lot of those problems stem from the fact that service ownership and the people that are responsible and the people that can control these services, rather than all sitting together in the same team, now they might be spread across multiple states, multiple time zones, even all across the world, or even, divvied up into a lot of smaller teams at one particular office. But that makes it hard for any one person or even a group of those people to really kind of keep an idea in their head of what everything is doing and how it all fits together. When performance starts to be impacted by this, right, when you start to kind of have problems, that becomes a very, very large issue with the way your developers interact with systems and the way that you're actually writing and deploying this new software. That manifests as lack of confidence, right? And that's kind of in two ways. One is you have a lack of confidence in sort of the aggregate performance of your software because, in large part, you aren't able to express things as a single number anymore, right? Like the traditional sort of, hey, how long did it take, when I click this button in the application, how long did it take for whatever operation to succeed or fail, maybe isn't as helpful as it used to be because the actual action that clicking a button represents is so much more than just, dozens or hundreds of lines of code. It's now 10, 20 different services kind of doing their own thing in some sort of coordination spread out across multiple regions or, different managed services. This also means that when you want to change your system, when you want to, add a new feature or try to solve some sort of performance regression by releasing new code, you have a lack of confidence in what's actually going on. You're not able to deploy reliably because you're not able to understand what's changing. So I said deep system a few minutes ago, and what is this? What is a deep system? So let's dive into that idea some. Fundamentally, a deep system is a distributed architecture or some distributed software where the thing that you can control and the thing that you can actually, control, so that your team's service or services are reliant on sort of this multi-layered architecture, right? Now, if you look at the diagram here, you can see up at the top we have, this is our service we're looking at, and then below it, I've got all these other services that I'm dependent on. Now, these could be other microservices that I've built in-house, and I'm responsible for, things that the company controls. But they could also be, managed services, right? If you're using some sort of external API for a managed database, right? That's a service that you don't really have control over, but you are responsible for its performance. And if its performance is flagging, then that's going to be a problem for you. In a certain sense, this isn't really a new problem. We've always had this. Back in the, even in the early days of microcomputing, you ran a program and the operating system you were responsible for the operating system in a lot of ways, right? But it didn't change that much. The underlying components that you were dealing with were pretty static. Now, the things that you're responsible for, those lower layers of your system, can change every day, every hour even, depending on how quickly you're able to release. So if all this sounds, kind of familiar, maybe you're already in a deep system, right? And if you're sitting here thinking about migrating to microservices or preparing to do some sort of digital transformation, then you might be looking at this saying like, oh, that's kind of what is coming up next, right? That's the stuff that I have to look forward to. And that can be really scary. That can be something that you're not going to have a lot of ability to manage with traditional tools, especially traditional monitoring tools. So when you think about how you sort of monitor and understand the performance of your applications and your services today, how do you do that, right? Well, you probably have some dashboards. And those dashboards are going to show you metrics from your infrastructure, memory or CPU consumption. Maybe they'll show you sort of some KPIs and some metrics like, how many requests are coming through your system. But all of those are really, high-level aggregate numbers that don't necessarily tell you the true story of what's going on. Traditional tools, like you can see, maybe you have a spike in errors. So you then go into logs, and you have so many logs. As you add services and as you add complexity to your system, the amount of logs you're creating will increase exponentially. And that's a lot of data that you have to go through, and that your developers are going to have to sit there and kind of go through this haystack and try to find the needle of truth. So we've moved as an industry into this sort of new paradigm where it's not just about, you can't use these traditional tools and have observability or be able to observe what's going on in your entire application. You simply can't. It's going to break down. You're going to have problems. We'll go more into those problems here in a moment, but it's going to be a bad time. So what observability focuses on is it moves us away from these traditional tools and into a state where you can observe the entirety of your application, all of your services, and all how they're working in concert without having to be limited to focusing on just this little window. One way I like to talk about this is trying to observe kind of your distributed system with traditional monitoring tools is like trying to figure out what a house looks like by only looking through a window, just one. And you don't know which window you're going to get. Maybe you get the window into the bedroom, or maybe you get the window into the kitchen. And you can look through that and you can say, like, okay, there's some pots and some pans, and I see a sink, so that's probably the kitchen, cool. But that narrow view doesn't tell you anything about the rest of the house, and it certainly doesn't tell you about the state of the rest of the house, right? The rest of the house could be on fire, and the kitchen could be fine, and you wouldn't know because you can only look at the kitchen. Conversely, maybe the kitchen itself is on fire, but everything else is fine. If you only have that narrow window, you can make incorrect assumptions about the state of the entire system by being too narrowly focused on just what you can see. Observability lets you step back and get the view from the curb, as it will, right? So what we see is those traditional systems tend to lead to these kind of negative experiences with people, right? Everyone's too busy looking through those little windows, and what that leads to is things like information siloing, and it leads to a reliance on tribal knowledge, right? Or it relies on almost like mysticism in some cases. I mean, how many people have heard like, hey, the application's down, let's go reboot the server, right? That usually fixes it. I certainly know that when, the first thing I do when my computer doesn't work is I turn it off and on again. But that's not really a good answer when you have, a business critical, production service that you're talking about, right? Like just turning it off and on again, maybe not what you want to do. You can also deal with having to be over-reliant on a couple different people, a couple different experts in your organization that maybe they came in, they had a lot of great ideas, and it's like, okay, we're gonna fix this, we're gonna give you monitoring, cool, and they're the only people that know how it works. And so anyone else, either has to be gated by those individuals and everything has to go through them if they leave or if, things change. Now, nobody knows how it works. Everyone just knows that, well, the dashboard means this. I think, you become very reliant on either experts that can interpret this data for you, like an oracle, or you become reliant on, just general tribal knowledge of how things are supposed to work. Like I said before, all of this has a lot of costs, right? And those aren't just costs to the business in terms of finance, but they're costs to, sort of the mental well-being of the people that are responsible for maintaining these, systems. So if you have a monitoring approach that isn't really smart, it isn't really modern, then you're going to spend all your on-call time, and you're going to have more on-call time from your developers trying to track down issues and trying to track down bugs and trying to track down performance regressions. And that means you have less developers working on shipping new features. Both of those together lead to sort of this apathy, fatigue, burnout in your development teams. I mean, I've personally seen this at other companies where, the problems just keep compounding, and so you need more and more people to be on call. You need more time devoted to tracking down these bugs and trying to, fix performance regressions. And things sort of slow down on shipping new features, and that leads to sort of a cycle where people are just kind of going through the ringer and going through, 70, 80-hour weeks trying to, make the thing work, which means that the quality of your actual features you're shipping aren't quite as good. That also means that people that are sort of the ones that are always in the trenches become, these experts. They become these oracles, and now everyone depends on them, or on particular Confluence pages, maybe, particular wiki pages, where it's like, oh, that has all the information on it. You just need to go there, but it doesn't get updated as much as you might like. This all kind of leads to bad outcomes for the business, right? Or for your customers. So if you're running something that's kind of like customer facing, people aren't going to be happy. They're going to see like, hey, this is, it's slow. It doesn't work well. There's a lot of bugs. I don't trust this, right? And that lack of trust is going to come back onto kind of your brand overall, not just on whatever piece of software it is. And this could be internal or external. If you have, poor internal systems, people are going to that's going to reflect poorly on sort of the internal culture as well. Finally, all that results in lost revenue, right? It results in a bad outcome for everyone involved. So what do you need? Well, what do you need to fix all this? I've doom and gloomed us for about 15 minutes, and I hate doing that to people because there's enough doom and gloom in the world already. I would much prefer to talk about how to fix these problems. So the key thing is this. It's not enough to look through those windows. You need to be able to look at the entire house. You need to be able to have visibility across every service in your application, every dependency of those services. Those are not just, service dependencies. Those are also, code dependencies. Those are also managed service dependencies, right, from a third party. Those are the APIs that you rely on through other providers. It's everything. Everything that your software needs to go, you need to have visibility across it. CI/CD, third-party APIs, managed services, other services in your deep system, everything. So the right way to do this, the right way to have observability, is to keep in mind this definition. Observability isn't just a tool. It's an entire way of sort of thinking about this telemetry data that's coming from your services, right? Your application is emitting logs, and it's emitting metrics, and it's emitting traces, and it's emitting all this data. So you need a solution that is able to sort of aggregate that and help you make decisions. It needs to be something that can easily see and understand your entire environment, your entire, all your services, all your dependencies. It needs to be something that can pinpoint regressions in those services and their dependencies without having to, wait to run reports or have a lot of human time, going through and trying to interpret charts and graphs. It's something where your developers can rely on the tool to ship and deploy new features with confidence and new versions of software with confidence. It needs to be something where it's easy to share. You need a humble tool. You want something that anyone can use, from your front-end developers to your back-end developers to sort of, managers and business analysts and other people. Because really, if you think about it, everyone in this organization, everyone in the business depends on your software to work. And you need some tool that is going to be able to provide everyone sort of, an accessible way to get at that performance data so that they're able to understand what's going on as well. You need a solution that isn't going to, throw away context or reduce in resolution over time. Sometimes you want to compare performance over weeks or months, right, without sort of losing fidelity. You want a solution that is able to accurately monitor the requests as they go from service to service to service without sort of collapsing all that into just one number. And finally, you need something that won't miss any insights, that's not, preemptively throwing away data that might be useful for you in trying to track down a regression, or figure out what's going on during an incident. So this may surprise you, but LightStep, as a tool, provides these wonderful features. But don't take my word for it. I'll tell you how to try it for yourself later on. But I do want to highlight a couple of really cool things that we do at LightStep that I think would help everyone listening to this, right? If you're trying to, if any of this stuff I've said so far sort of resonates, we provide an answer for sort of that anxiety and those problems that you might be running into or will be running into. How do we do it? So it might help a little bit to understand sort of some of the backstory about LightStep. As a company, we were founded by experts in the industry, people that were building and shipping microservice architectures at global scale, years before it really hit the big time, right? Our founders are from Google and other places, so they know what they're talking about, right? They have been implementing these sort of architectures for a while. And what they saw was these are becoming increasingly popular. Software is eating the world. Microservices are becoming, this very almost dominant pattern of development. And people are going to build these, and they're going to be stuck in a hole where they aren't going to understand what's going on. So we need to, take what they learned and build it as a product for everyone to sort of access. So what did they learn? They learned that you have to have end-to-end visibility for requests in your system. There's no other thing that really comes close in terms of being useful data for you when you're trying to, either improve or restore performance. You need to be able to catch outliers all the time, not just some of the time. You can't rely on an even distribution of errors when you are dealing with like a regression or some sort of incident. And finally, they know that we're living in this world where the thing that really matters is how fast are you shipping new code? How quickly can you iterate? How rapidly can you release? And for any of those, to do any of those, you are going to have a way to understand what's happening when you release, what happens after you release, right? How can you have confidence that the changes you are making are actually improving, performance or creating a better user experience? So with LightStep, we are able to automatically detect when you've deployed new versions of a service, and we're able to do regression analysis and tell you, hey, did something change here? Did performance get worse or better? We're able to show you your entire system architecture, and we're able to show you in that system architecture, where is latency coming from? Where are the problems occurring? We can show you the critical path of a request as it moves through that system architecture as well. We can give you real-time and historical root cause analysis through functions like correlations. Correlations will show you attributes or operations that correlate with latency. A good example of this is maybe you have a request that 1 in 10 times is slow. Why is that? Correlations can help you determine that it happened because a particular database server is slow, or a particular region is having poor performance right now, right? Or maybe it's a new version that's only being hit so often. That's what the problem is. LightStep can automatically detect that for you and point it out without you having to, again, have pre-built a bunch of dashboards or your monitoring to look for that sort of stuff. And then we can alert on that. We're built on open source, so we use open tracing and then in the future open telemetry, which are two open source packages to generate this telemetry data from your software. We're very committed to those projects, and because we believe that you should be free to, you shouldn't be locked into a particular, solution, right? You should be able to go and do what makes sense for you. And so instead of proprietary agents or proprietary APIs, we're built entirely on open source. So finally, we have no cardinality limitations and no limitations on like custom data or custom attributes or custom tags, right? So you can send us any combination of tags or operation names. You can create custom attributes in those as much as you like. No extra charges. No, we're not trying to make you send us less stuff, right? We're not trying to say, you need to be nickel and diming your entire sort of monitoring and observability strategy based on how much it's going to cost for you to look at that data later on. You need to just be able to send everything, and then through our dynamic sampling approach, we will figure it out for you. So you may be asking, well, how does that part work? So at a high level, what we do is your services, your monoliths, serverless functions, any kind of code you're running, any kind of service you're running is capable of sending telemetry data to what we call satellites. And you run like a pool of these satellites, and we also can run the satellites, but you send that data into them. And then 100% of that data is analyzed by LightStep. So we're able to use that and then create sort of aggregate statistics for your golden signals, such as latency, operation rate, error rate, things like that. We can also ingest data from other tracing tools like Jaeger or Zipkin. We can ingest data from mobile clients. Basically anything you can think of, we can take the data from, as long as it is in a trace format. So once it's in there being analyzed, we keep all of it for a length of time that kind of depends on the amount of data, but usually 10, 15 minutes. And while it's there real time, you can actually query this from our SaaS product, right? So you can go in and you can look at everything happening in real time, no delay. You don't have to wait 5 or 10 minutes for things to happen and then see if something changed. You'll actually see in near real time, a couple of seconds, like, hey, here's something that's happening. So instead of having to wait 5 minutes to know your system is down or that there's an error on your new version of a service, we can tell you almost immediately, which is really cool, I think. Over time, once stuff is after that, we do some dynamic sampling on it and store it for a length of time that you determine. So if you'd like more information on that, I encourage you to reach out to us and we can go into or hit me up on Twitter. We can go into a more technical conversation. But at a high level, this is a different approach than you would see with a lot of traditional APM companies, where there's a lot of upfront sampling, where basically instead of you're reducing the amount of data sent from your process to like 10%, we're saying 100% of the data from that process into the satellites. So we do this cool thing, and people have been using it. People seem to like it. I think there's a couple of success stories that I kind of want to end on here, just to let you know some of the real world use cases that people have come up with. So you can read here, people are finding latency bottlenecks. They're getting increased visibility into all their services. They're debugging issues in production in seconds. And what we've found with our existing customers is most people are solving problems in about 1/10 of the time than they used to. So let me actually jump into some specific use cases here, some specific customers. Here, Twilio, their messaging API, they let you send phone calls and do texts and stuff like that. I think some other stuff too. But one thing, when we started talking to them, they wanted to be able to identify like specific events in their requests. And what they had was this logging solution that they had built. And they were continuously analyzing these logs from over 40 services. And the problem they ran into was, one, there was a lot of overhead because it was just continuously going through all these logs files. But two, it was very expensive to sort of build and maintain that platform for monitoring the logging data. When they switched to LightStep, what we found was the model, the observability model we provide is really helpful, because what they were looking for really was that they were looking for both. They wanted to be able not only to get the curbside view of the house, right? They wanted the macro view, but they also wanted to be able to go and kind of look into those windows still and drive all the way down to, looking at one particular service, one particular request in great detail. And LightStep can answer both of those questions for you. So their average MTTR, mean time to resolution, their root cause analysis went down from about 40 minutes to under 3 minutes, which is 20 hours a week that they were saving in terms of, trying to respond to incidents, which is huge, right? That's 20 hours that they can get back for, building new features, 20 hours they can get back for, not having to work late, right? Like mental health, things like that. Those are all, I think, really important and powerful because it's all super useful stuff, You don't want to be staying late at the office every night. It's going to impact your ability to actually do anything else the next day. So Under Armour is another one of our customers. They were shooting to have 100% visibility. And as I mentioned before, LightStep's capable of doing this, and we did in their case. They have a pretty wide range of different applications, some of them mobile, a lot of back-end stuff. It's just a huge variety. And what was important to them was to be able to understand how requests were kind of moving throughout everything. So before, there was a lot of fear. They had a lot of fear about going on call, and no one really wanted to take the pager when a new release of a feature was, or a new service release was going out, or there was an incident. And the reason why was because of this complexity, right? So LightStep, by giving them this sort of macro and micro visibility, allowed them to make it a lot easier for people to be comfortable saying like, oh yeah, I'll take the pager, right? I'll ship the new version of this. They're going to know immediately if something goes wrong because LightStep is able to sort of automatically figure that out for them. Another big benefit they saw was with how LightStep handles context, right? So it's not just sort of that high-level performance number. It's not just, that one thing. It's every single step in the chain. It's being able to look at every service that's participated in a given request and understand exactly what changed between, a successful request and a failed request, right? We help them change their thinking about performance and about, how do you measure reliability, right? Finally, I think the other big thing I think they found was, again, we are a humble tool. We're an unselfish tool. So rather than having complex dashboards and sort of arcane log searches, they were able to get these really clear graphs and charts in the LightStep tool to really understand, what exactly is the user experiencing in this case, right? Like, what is going on at every sort of hop in a given request, and how is that actually impacting the user, and how is it impacting sort of users more broadly, right? So it's not just because quite often there's a distribution, right? There are some people that are having a very, very poor experience, and there's some people that are having, an okay experience. And at some level, you have to do some triage, right? It's maybe unreasonable to expect 5 or 6 nines of uptime for every single person in every single case. The way that LightStep is presenting this data lets you really understand exactly who is being impacted, how they're being impacted, and it's something that everyone can use, not just sort of your back-end engineers or your SREs or your DevOps or whatever, something that the front-end people, the mobile developers, everyone can jump into on an equal footing. So if all of that sounded interesting or sounded like something you would like to know more about, then what I would encourage you to do is 2 things. The first one is this. So we have a thing called the LightStep Sandbox. You can go to it, lightstep.com/play. What this is going to let you do is you'll get a couple scenarios that you can go through. And at each of those, it's using real data. It's the actual 100% product that you would get normally. And you can go in and kind of work through some challenges, right? We'll help guide you along, and we'll sort of show you where to go. But what you'll see is, and you can compare, it's stuff that you've probably done before if you've, been in this a little while. It's figuring out regressions. It's understanding latency. It's understanding, it's monitoring a deployment and seeing what changed. It's pretty common tasks that many of us may have done hundreds or thousands of times in our lives, but it's a completely really new way of thinking about how you do those tasks. And I think the best way, I could jump in here and show you something on my browser, but it's not going to really be a replacement for you doing it yourself. So again, lightstep.com/play, go in there. You just put in your email and there's no charge or anything. And we will kind of set you up and take you through it. Takes, I don't know, maybe 5-10 minutes of your time, if that. It's a great coffee break hobby. Yeah, I would say that would be the best next step for you. The other thing you can do, we'll have these slides available, I believe, tomorrow or in a follow-up. And if you have any other questions that, may have come to you while I was talking, I believe we have plenty of time for Q&A. So I would love to take any of your questions. And yeah, thank you so much.
Thank you very much, Austin. We're going to move on to questions from our viewers. First question, how is LightStep different from New Relic and Datadog?
That's a great question. And I definitely hear that a lot. So like I was saying in the presentation, LightStep is a observability platform. We take this tracing data, these logs and tags and so forth, and present them to you in a way that is, unique from a Datadog or a New Relic, rather than having to have, multiple different dashboards, multiple different tabs in your browser where you're kind of clicking back and forth and trying to manually correlate things. This is all in one seamless sort of user experience. A couple of other big distinctions. We don't have an agent. We do offer like some automatic instrumentation agents that you can use, but there are, just simple integrations that you can add to your code where the data is coming straight from your process. So there's no additional overhead of running an agent on every single one of your containers or on your VMs in order to get this data. Finally, we don't charge based on the amount of data you send us. Our pricing is entirely around how many services you have reporting and how many people can use the application. Also, so it's not a count of services. It's not like how many instances of service you have. It's literally like if you have 10 services, let's say, and some of these services will scale to maybe hundreds or thousands of instances, you still pay the same as you would for one instance of that service. So we were able to do this because of our architecture with the satellites that I showed you earlier. If you'd like to know more about that, again, please, we'll get in touch with you or you'll get in touch with us, but we're extremely competitively priced against traditional APM and monitoring tools.
Understood. Thanks, Austin. Next question, what is the difference between APM and observability?
That's another great question. So I would say APM is focusing on one specific type. APM is almost like it's looking at one thing. It's just looking at the performance of a request, sort of disconnected from other things. Observability is not just the tooling required to sort of look at requests and logs and metrics and all that sort of stuff from the 10,000 foot view, but it's sort of the processes and the practices that you're able to do with that. It's like I was saying before, I find it quite common when I go talk to people that they have, either a team or a handful of people that kind of, quote unquote, run monitoring, run APM, and the knowledge is very siloed. And I think some of that is kind of by design because a lot of APM tools tend to be very expert oriented and they tend to be somewhat inaccessible to people that aren't doing it, every day. Observability is not only, this style of sort of performance monitoring and collecting this information and displaying it that democratizes it and makes it something that everyone can sort of get into evenly, or equally, I should say. But it's also about how you're using that information to make decisions about what you should do next, right? So one thing that I've talked to some of our customers about, they're actually using LightStep as sort of part of retrospectives, right, and as part of sprint planning, and they're taking the data that we can give them and then using that as feedback into figuring out, well, hey, here's what we should work on next, right? And And it's those practices of of using this data to make decisions about how you should do engineering and about how you should, about what you should work on next and how you should, organize your team, or what's the most important, what's the next thing. Like, I think that's also a really important part of observability that LightStep helps unlock for you.
Understood. Thanks for clarifying. Our next question, are there any open source components to the LightStep platform?
Yes, there are. Thank you. It's a good question. So LightStep, to the customer or to the person that's using it, is entirely open source. All of our tracing libraries and integrations are completely open source. As I said, we are big supporters of open source, are heavily involved in open tracing, which is a open source project that seeks to standardize the API for distributed tracing and telemetry. We're also we're very heavily involved in open telemetry, which is sort of the successor to that, working with companies like Microsoft and Google to ensure that cloud native software has a single well-supported way to create telemetry data for observability platforms such as LightStep. So all that is available on GitHub if you want to go look at it. You can also check out on our website, we have some information about open telemetry and open tracing as well, and that will give you links to the appropriate places. Or if you want to talk more about the open source stuff, hit me up on Twitter. I'm a maintainer on open telemetry, so I can probably answer some of your questions.
Thanks, Austin. What are some of the key things you'd like our attendees today to keep in mind as they move forward?
Key things. I think if I had one thing, this is what I talk about a lot personally, is the real goal of all of this is, the real focus of all of this is not, about software. It's about software in the sense that software is built by people and it's built for people. That could be your coworkers, that could be other engineers, that could be your customers, whoever it is. But keep in mind why you're doing all this, right? One thing I see a lot, at least on Twitter, is people are like, oh, this is great. How do I build it myself? And I always say it's like, well, you could. There are plenty of open source tools that will help you, build something that's sort of like this if you turn your head and squint. But is that really the best use of people's time? If you have, your company, your whoever, whatever you're doing, you probably have something that you do better than anyone else, right? It's the point of having a business, I guess. And maybe that's, hotels, or maybe that's, ordering cars, or maybe that's shopping, or whatever. But you should focus on being the best of the things that you're the best at, and then, don't make people go out and try to clone observability platforms. Because one, I don't, humbly would say the people that are building those observability tools are experts, right? They have a ton of experience in doing this, and you're going to get better bang for your buck by paying a little bit of money to use one of those than you would be forcing a bunch of people that maybe don't necessarily want to build an observability platform to build an observability platform. And the flip side of that is, people will do good stuff if you give them access to the things they need to do that good stuff, right? So make sure that the tools that you're picking are unselfish tools, that they are humble tools, right? They should be something that anyone can use and doesn't need to go read a book on how to, you shouldn't need to go read a book on how to build a query, right? Things like that should be pretty simple, I think. So look at the tools you're using now, and if they are things that need people to really be experts in order to interpret, I think that can make it a lot harder to find adoption. And the last thing I would say people should do is they should go to lightstep.com/play and try out the LightStep sandbox. Because, again, I think that's the best way to learn what we're about. is to go through that sandbox.
Understood. Once again, I'd like to thank our speaker today, Austin Parker, Principal Developer Advocate at LightStep. If you would like to review this presentation or send it to a colleague, please use the same URL that you used for today's live event. It will be archived, and you'll receive an email tomorrow once the archive is posted. And once again, just for participating in today's event, you could win this $100 American Express gift card. The winner will be announced on February 28th. We will reach out to you via email if you are the lucky winner. Thank you, everyone, for joining us today, and we hope to see you again soon.
Thank you, ladies and gentlemen. This concludes today's webcast. We appreciate your participation. You may now disconnect. Presenters, please stand by.